All right, so starting our new unit, I just want to point out to you how happy the students look at the beginning of our chapter. I mean, this looks like a lot of fun. If you like puzzles, this should be your favorite chapter of the book. I'm just saying, okay? So first off, a little bit of review. Hopefully you remember these identities from last chapter, right? Sine is reciprocal of cosecant, cosine's reciprocal of sine or secant, and so on. You also might think, instead of thinking like this one, remember that also means that cosecant of u is equal to 1 over the sine of u, right? And remember, this one also means that the secant of u is equal to 1 over cosine of u. And this one also means that the cotangent of u is equal to 1 over the tangent of u, right? So you want to remember those things. Also, these, right? Tangent, sine over cosine, cotangents, cosine over sine. Pause the video, write those down so you have them. Okay. We're going to learn 4 things in this chapter, right? First, we're going to evaluate trigonometric functions. Today, and for the next week, we're going to be spending time on simplifying these expressions. Along the way, we will develop additional identities, like we're going to develop 3 identities today. And then the big part of this unit is to solve trigonometric equations, right? We want to solve equations that have sines, cosines, and tangents in them. Now again, this simplifying involves adding, subtracting, multiplying, dividing, and so on of these identities. So we want to figure out, what's sine times cosine, things like that. So first, we're going to simplify some. And a good rule to follow is when you're not sure what to do, like, man, I have no idea how to simplify this. Sometimes a good technique is to rewrite everything in terms of sines and cosines. So for example, this one on the left here, we know that cotangent is the same thing as the cosine of u over the sine of u. Now we're still multiplying it by the sine of u. So our first step here was just to rewrite in terms of sines and cosines. Now we notice that these cancel, and so we're left with cosine of u. And that is definitely less writing than the original problem. That's been simplified, right? So just like, we want to simplify fractions, we want to simplify trigonometric expressions. So go ahead and pause and try to do this one, all right? When you're ready, unpause it and watch me do it. All right, so what we're going to do is we're going to rewrite the secant in terms of sines and cosines, which is 1 over cosine of x. And now when I multiply this, we are going to have sine of x over cosine of x. And well, what is the sine of x over the cosine of x? Well, that is tangent. And there's our simplified step. Okay. You all try the one on the left. Pause it, work it out, and then I'm going to work it out and check your answers. All right. So again, rewriting in terms of sines and cosines, secant is 1 over cosine of x. And when I multiply through, I think the cosines cancel, and we're left with the number 1. That's simplified. That makes sense, right? Cosine times its reciprocal should be 1. Okay, pause the video, try this one. All right, let's rewrite this. Now, tangent is sine over cosine. Cosecant is 1 over sine. And when we multiply, those cancel, and we're left with 1 over cosine of x, which is almost there. Now, 1 over cosine x is really secant of x. And there's our simplified answer. Okay. The one on the top left, I mean, there's a lot of ways to go about doing this one. One way is just to immediately rewrite in terms of sines and cosines. So maybe, you know, I think I'm going to rewrite in terms of sines and cosines. I think that might work. Again, there's a lot of ways to approach these questions. Now, cosecant is 1 over the sine. Now, when I distribute this, I think that's going to cancel, leaving 1. And then when I distribute again, we're going to have sine squared of x. Now, we're going to need to come back to this one because this one can be simplified further, but we need to develop an identity first, okay? So remember, we got to come back to this one. All right, you all try this one out. Pause it, work it out, and then watch me. All right, so I'm going to rewrite this in terms of sines and cosines. Now, secant is 1 over cosine, and then cosecant is 1 over sine. Well, we've got a fraction over a fraction, which means it's the top fraction, right, divided by the bottom fraction. And we know that when we're dividing fractions, it's really the same thing as multiplying by the reciprocal. Now notice I'm not using an equal sign, I'm using an arrow saying, hey, here's our next step. There's no equal signs in these questions, so please don't put them in. These are expressions. When I multiply through, I get sine of x over cosine of x, which is tangent of x. Okay. All right, pause it if you need to look at it. I'm moving on. Okay, I want to develop 3 identities for us. So what I've done is I've drawn the unit circle here. And I'm going to put a triangle in there. You know, like bow tie question, right? It's a unit circle, so the radius of the circle is 1 unit. Here's theta down here. And his point is at x comma y, which means it goes over x and up y. So the sides are that, right? Now, there's some trig that I can do. I know that the sine of theta, right, is equal to y over 1. The cosine of theta is equal to x over 1, right? Now, I can also, in this problem, I can notice that in this triangle, I can do a Pythagorean theorem, right? Y squared plus x squared is equal to 1 squared, right? Pythagorean theorem. And over here, you'll notice that y is equal to sine. So I can change this y to be sine. So there's sine squared of theta. X is equal to cosine. I can plug that in for the x. And 1 squared is just 1. This is the main identity. It's called a Pythagorean identity. Why do we call it Pythagorean identity? Because we use Pythagorean theorem, right? Now there's 2 other ones. So the first one, you want to write this one down. Sine squared plus cosine squared equals 1. We're going to derive 2 other ones just to get the answers, right? So what I could do is I could take what I just did here, and I could divide everything by sine squared. And if I do that, I would have, I'm going to put it up here in the corner. See, sine squared over sine squared is a 1. See, cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. So that's another Pythagorean identity. Pause it if you need to look, because I'm going to erase. Okay. Now, instead of dividing by sine squared, I could also divide by cosine squared. And when I simplify that, well, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So, these are the 3 Pythagorean identities. You need to memorize these. Every day in class, we're going to spend the first 2 minutes of class practicing these. Going to make sure you know them. Again, if you know sine squared plus cosine squared equals 1, you should be able to derive these 3 ones up here, okay? So, you need to keep writing, pause it and write it, otherwise I'm going to move on. I want to go back to the one I set up here. I'm like, hey, this one, right? So, we can do a little bit more here. Now, we know that sine squared plus cosine squared is equal to 1. Well, this expression says 1 minus sine squared. Well, if I were to subtract a sine squared from both sides, we would have our answer, which is, okay? Again, we're just trying to simplify these. And the whole reason why we're simplifying things is in math, sometimes when a problem is presented, it's impossible to do. We need to rewrite it in another format so we can figure it out. Think about the ellipses and hyperbolas and circles and parabolas. We did completing the square on those to get them to look like something that was a little bit easier to figure out. All right, let's look at a couple of these. So this first one here is factoring. Now, this may not look familiar to you, but what if I were to change it to be y squared minus 1? I think we would agree that is y plus 1 times y minus 1. Well, this is just in terms of trigonometry. So this would factor to be cosine of x minus 1 times cosine of x plus 1. The one right below it is another difference of squares. It just has a couple steps on it. This one is going to be sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. Now, we know that sine squared plus cosine squared is 1, so we can eliminate that, right? Now, on the right-hand side, I think that's enough. We would just leave it like this. Okay, and that would be perfectly acceptable. Okay, let's look over here on the right. This one may not look familiar, but if we were to change it to be x squared minus 3x minus 10, right, in terms of like an algebra kind of idea, we know that this would factor to be x minus 5 and x plus 2. Well, that's what happens here. This factors to be sine of x minus 5 times the sine of x plus 2, okay? And if this were an equation, we would then be able to factor it. Okay. On this one below here, this one here, we've got 4 terms, and so the idea always has been to do factor by grouping, right? So if I look at the one on the left, I believe I could factor out a secant squared of x. And that leaves me with secant x minus 1. On the right-hand side, if I factor a negative 1 out, we'll be left with secant of x minus 1. We factor out the secant of x